My name is Mike McLeod. I'm with the Frank J. Martin Company, the manufacturer's rep for EBA Iron. And this morning we're going to give a class, little presentation on joint restraint, pipe joint restraint, and specifically how the EBA Iron product line products can help meet the needs of the joint restraint market. And there's a lot of design type aspects and some technical criteria with designing joint restraint systems, but my goal is to make all of you aware of what's available and how to use it, and then what resources are available for you to get more of the technical information if the need arises. Where would someone use a megalug typically? That's a question.
On a fitting.
Okay, on an MJ fitting. And why would they use a megalug or some type of restraint product?
So that the fitting wouldn't blow off when there's pressure in the water line?
That's right. That's absolutely correct. And that is what we're talking about, which is joint restraint. That's good. EBA Iron is the name of the company. They're out of Texas, and they've been in the ductile iron foundry business since the late 60s. EBA Iron stands for Earl Bradley and Associates. It's a family-owned business. Earl Bradley is the founder of the business, and his associates are his family and friends. The nice thing about EBA Iron is everything is done in-house. They are their own foundry. They manufacture everything they sell. This particular niche, this joint restraint market niche, is all they do, all their research and development, all their engineering. Their focus in life is this one little niche category. So they invest in the latest technology and put a lot of time and energy into the product. So rest assured, there's a good product and a good company standing behind the products you're selling. Joint restraint is kind of one of those fuzzy topics in our industry, and you hit it right on the nose when you said it's their products used to restrain fittings to keep them from blowing off pipelines under pressure. And that's exactly how we describe it. When we talk about joint restraint and we have a 90-degree fitting and another piece of pipe, in a buried pipeline or an above-ground pipeline, doesn't matter. If there is pressure in this pipeline and there's a change of direction, a bend angle, then what happens is there is thrust generated or force generated that is exerted on this fitting, and that fitting wants to blow off. So without some type of restraint mechanism where the pipe joins the fitting, or a real traditional way to keep that fitting from blowing off, is the use of what's called a concrete thrust block. And that's very, very common, very traditional, and that is what EBA Iron and the other manufacturers that make joint restraint products are all selling against primarily, is concrete thrust blocks. So the concept behind a thrust block is basically it's a surface area calculation. The engineer or the designer will sit down and run the math, do the math, and what they are determining is, depending upon the size of the pipe, the type of the pipe, the depth of bury, the type of soil it's in, the amount of pressure in the pipeline, at a bend angle or a T or a 90, any change of direction, anything other than just a straight length of pipe, once there's a bend angle, again, there's force, there's thrust that's being exerted on that fitting. So what they do is they take into account all those variables, and then they size a thrust block, and a thrust block is basically a surface area calculation. So it's a mass of concrete poured behind a fitting. It has X amount of square feet of surface area that is taking all this force that's being generated by the pressure on this fitting, and basically it's transferring all this force to the entire surface area around the thrust block, and then the thrust block is transferring all that force to the undisturbed soil around the thrust block. And thrust blocks are no one's friends in our business, because last time I checked, I didn't see H.C. Fowler selling concrete. And we don't sell concrete, so we want to sell iron fittings, iron glands, those kind of things. So what we're trying to do is to teach contractors and municipalities to eliminate thrust blocks and use some type of joint restraint product. Now, assuming that a thrust block, just pouring a mass of concrete behind a fitting, is a real traditional way of doing things. Can someone name maybe a few ideas of why a city or why a contractor couldn't pour a bunch of concrete behind a fitting or behind a hydrant lateral or behind a T or something like that? In our world today, there are cable lines, sewer lines, fiber optic lines, gas lines, etc. If they, for some reason, happen to be adjacent to this pipeline, you can't pour concrete over their pipelines. So that's an excellent reality. Any other areas where pouring a thrust block might be not feasible?
You have an above ground assembly.
That's right, Nick. An above ground assembly, any kind of pipeline under pressure above ground has to be restrained somehow. And to kind of put it into picture, as far as historical perspective goes, if you look at all the different pipe valves and fittings that H.D. Fowler sells, your PVC pipe that you sell, the small diameter stuff for the irrigation systems, they glue those fittings together. That's a restrained fitting. When that half-inch line is under pressure and they're putting a half-inch Schedule 8090 on there, if they didn't glue that up, it would leak and it also would blow off under pressure. By gluing it up, it's restrained. It's keeping it restrained. Threaded fittings, threaded pipe and fittings, that's a restrained fitting. You know, all the above ground piping you see in the commercial buildings like the Home Depots, the Walmarts, those kind of things, that's all Victaulic type piping or threaded fitting for the fire sprinkler systems. All that piping is restrained. It's totally mechanically or screwed, connected somehow so that it won't blow apart under pressure and or leak. And that's the same type of concept that the EBA iron products apply to, but we're talking primarily for ductile iron pipe or for C900 PVC pipe or Class 200 PVC pipe in certain applications. So, and again, primarily they're used with ductile iron, you know, MJ type fittings or PVC fittings, push-on fittings. Okay, let's say for instance somebody's running a water line through a peat bog or a swamp or a marshy area, something like that. A poor soil condition won't support a thrust block. A thrust block, they may be able to pour it, but what happens is it'll sink over time, it'll settle over time, it may start to pull away from the fitting. If the fitting doesn't have the ability to transfer that thrust to the surrounding concrete because it's pulled away, then it doesn't have the ability to transfer that thrust to the surrounding soil. So poor soil conditions is primarily a #1 type application for us. But the real advantage to using some type of restraint product versus concrete thrust blocks or shackle rods or something of that nature is time, okay? The other real detriment to pouring concrete thrust blocks is they take at least a minimum of 24 hours to set up. And a lot of these contractors in cities, when they're running a line or cutting in a T or stubbing up a hydrant or something like that, they want to get it installed, they want to get it backfilled, they want to pressure test, and they want to blacktop and be off the job all in the same day or in a couple days. They don't want to leave an exposed trench open, let the concrete cure, wait 24 hours, wait 48 hours, then pressure test, blacktop, et cetera, et cetera. So time is money, and by using a product like this, they can basically install it, pressure test, get it passed, and go ahead and pave and get off the job typically in the course of a business day if they've got it scheduled properly. So there's no downtime for waiting for the concrete to cure. Another interesting issue that is becoming more and more prevalent, particularly in some of the larger cities and downtown corridors, any areas that have urban areas, is it goes back to the open trench, the exposed trench concept. A lot of cities used to leave their trenches open and waiting for the concrete to cure or waiting for parts to arrive, whatever the case may be, and they'd use the temporary steel plates. Well, there's been a number of lawsuits lately where people have slipped and fell and hurt themselves pretty severely on those steel plates. Hence, they sued the city. Now the city has changed their ordinances. if they're going to schedule work to occur in a downtown area, to the best of everyone's ability, they want it done that same day and blacktopped and paved that same day. They don't want that liability anymore, regardless of how well they try to draw attention to it, mark it, rope it off, etc. So liability is an issue that's driving all aspects of our businesses. The hidden benefit to using some type of joint restraint product also is a lot of the restraint products available on the market offer what's called post-assembly deflection. When a pipeline installer is installing a pipeline during assembly, typically you have some type of female fitting and you have a male piece of pipe, you are going to get some type of deflection, some type of bend angle during assembly. Okay, then you backfill and everything's good to go. Well, over time, the soil conditions have a tendency to move. There may be ground settlement, shift, etc. There may be a seismic event, perhaps. There may be surges in the line that create water hammer, which would put a lot of force on those fittings, etc. And one of the nice benefits and advantages to a restraint product, or the majority of the restraint products that are on the market, is not only do they allow a maximum amount of deflection during installation to kind of help make sure everything gets lined up and make sure everything's plumbed properly, but they also have the ability to offer post-assembly deflection. And what that means is once everything's all installed and tightened up and everything's good to go, if there ever is ground settlement or movement or some type of deflection, these glands have the ability to offer up to an additional extra 5 degrees additional deflection. So again, you just get a little bit of extra flex, and that's really important in stuff that's buried, because it's very rigid and not very well supported. And flexibility is a good thing, because when you don't have flexibility, you get breaks and then there's problems. That's one of the primary reasons why flange piping is not very commonly used underground anymore. Too rigid, no deflection. That's what really one of the major benefits of a mechanical joint type connection. A lot of deflection, very easy to assemble, and a very time tested type proven joint. We're trying to take pipe, restrain it, basically tie it all together, make it all one. And what the joint restraint products do, let's just pretend my elbow is a 90-degree fitting, and then I have a length of pipe and a length of pipe. Basically, by restraining the fitting to the length of pipe on this leg and restraining the fitting to the length of pipe on this leg, what we're doing then is essentially we're eliminating the need to have a thrust block, and by locking it all together, what we're doing is we're turning this entire pipeline into the thrust block. And then all the surface area of the entire pipeline becomes the thrust block, and it is all transferring that force and thrust to all the soil surrounding it. So again, we're just turning the entire pipeline into its own thrust block rather than having a separate thrust block there with the same amount of surface area doing the same thing. So quick, easy, and you hit it right on the nose. Lots of applications, where to use it, why to use it, poor soils. You don't want to use concrete, existing sewer lines, cable lines, utility conflicts, etc. There are two primary types of restraint products for mechanical joint fittings on the market, and there's basically our 1100 series, which is for ductile iron pipe, and then there's our 2000 series for PVC pipe. And I brought our demonstration trailer along, which will jump out in the yard, and it has all the products on it, so we can quickly show you what they look like. But for identification purposes for you all in the yard and pulling and shipping and quoting and customer service functions, all of the megalugs for use on ductile iron pipe are black. All of the megalugs for use on PVC pipe are red, reddish, orangish is kind of the color, okay? So now what do you think about the ability to mix and match? Does anybody have any thoughts on there? Could I use this on PVC, or could I use the PVC one on ductile? Neither product is for the MJ, for the mechanical joint fitting, is interchangeable, okay? So you can't take the ductile and put it on the PVC. You can't take the PVC and put it on the ductile. That's very important. because sometimes you know what happens. The wrong product will get out on the job. One of you may get the call. The answer is no. Okay. The reason being, the wedge assembly, the tooth that bites into the pipe, that restrains the pipe and keeps it from moving. The tooth for biting the ductile iron pipe is an aggressive tooth, and it makes a pretty good impression on the pipe. It would be too aggressive for the PVC pipe. The wedge, this is also a hardened wedge, by the way. They anneal this, they put it in an oven, they anneal it and harden it. And the reason it's hardened is because it's hardened so it can actually bite and penetrate the ductile. It needs to be harder than the softer ductile to make an impression to keep it from separating. Conversely, the wedge assembly for the PVC, this is a 6-inch gland right here, 6-inch megalug. There's only 3 wedges for the ductile iron pipe. If this was a 6-inch PVC megalug, there would be 6 wedges. So we grab the pipe in, as a rule of thumb, twice as many places, 6 wedges as opposed to 3 wedges, but also those 6 wedges have a much shallower bite. They have a much shallower tooth, and the tooth is much wider. So it's a wider pad, and it's a shallower impression. More surface area to grab, and much more forgiving on the PVC pipe. Okay? So that's one way to identify in the field, and the megalugs for MJ, for mechanical joint fittings, hydrant shoes, etc., that really represents the majority of the business too. There's a lot of other products that we manufactured for push-on joints and bell joints, and there's repair products, split megalugs, those kind of things, and all that stuff's on the trailer, and it's easier just to talk about that when we're out there looking at the product. So we'll do that, but for identification purposes, there you go. Now, one thing that you will notice coming through your inventory, which we're very proud to say, and it's exciting, Richard, that you've been to East Lynn and seen Earl's place there. Again, he's not shy on reinvesting in the business. He's very proud of his product, and he wants to always offer the industry the best product available. Something that we are doing now at no additional cost to our customers is we have just implemented a new multi-million-dollar coating facility, and basically all of our glands through 24-inch are going to have this polyurethane coating on the gland, and all of the wedge assemblies have this Xylon coating all at no charge. And what we're doing there is we're offering something that is going to offer superior corrosion resistance above ground as well as after installation, as well as much easier to handle. You know, the old coal tar epoxy type coating that was on these things really was just a painted surface to minimize surface rust during shipping and handling and storage and those kind of things. And what this coating is offering is better long-term corrosion resistance for municipalities that are concerned about corrosion. You know, some of your municipalities on the coastal areas, saltwater areas, bays, etc., they have concerns about corrosion. The nice thing about the Xylon coating on the wedge assembly is the way that these wedges work is the operator will twist these wedges in a clockwise manner, and the collar bolt is threaded into the wedge. The nice consistent Xylon coating on the wedge helps maintain a real consistent torque value on these bolts and nuts. And what happens is when these nuts reach about 90 foot-pounds, these will shear off. Okay, and that's an installation tool. That way the installer knows that the product was installed properly. And a lot of times, you know, we're doing this, obviously we're doing this in the ditch. That's the common installation. A lot of times dirt and muck and gum can gum up these threads and distort some of those torque values. So this new coating system is going to greatly enhance more consistent torque values and ensure much better installations over the life of the product. one feature that the Megalug offers is all of the wedge nuts have a twist-off nut, and there's a directional arrow cast into every nut. The direction is clockwise. We want these tightened clockwise. So basically, our installation is no different than WWCL1, which is the AWWA spec for mechanical joint pipe and fittings. As this gland is installed into your mechanical joint fitting, there's a gasket here that's making the seal. Lubricate your gasket, okay? That's always commonly overlooked, but that's something that we all ought to remind our contractors and city people to do, just as a reminder. They commonly don't like to lubricate the gaskets a lot because it gets all over their hands, their clothes, it's messy, and depending upon the type of lubricant they use, it also can attract sands and fines, which potentially could hamper their sealing ability. However, AWWA requires that in that specification, and we also recommend it. It's very important to lubricate that gasket to help ensure that it flows into the cavity and to maintain a proper seal and to prevent cold flow of the gasket, which could cause a leak. But we recommend lubricating the gaskets. The installer will install the T-bolts into the fitting. Okay, typically they'll run them up in a star pattern, get them all nice and snug, and then depending upon the diameter of the gland, there's different torque specifications to draw these in to make a nice, even, consistent seal into the MJ fitting. Typically what that person's doing is, hopefully they're doing it in a star pattern. A lot of times they're using impact wrenches, which not necessarily can be avoided, but there are specific torque values they should be using, and a lot of times they'll just check to make sure everything's centered by checking the distance of the threads. If all the bolts are 1 inch sticking out, they figure they got it in there evenly. So once the gland is installed in the fitting in that manner, we have a seal, okay? The seal's there, no different than you would with any other MJ gland where you would have a thrust block behind that fitting. Now, when it comes to the restraint, the addition of the restraint is these wedge assemblies. And again, doesn't matter if it's an aggressive tooth for ductile or a shallow, milder tooth for PVC, but the additional step to set the restraint is then to properly engage these wedges into the pipe. And the way that is done is you can hand tight or use a wrench in a star pattern. The larger diameter, you have a lot more wedges, so it's easier to do in a star pattern than you would with just 3 like you have here. But you try to, again, draw it down consistently, get it even, get it centered in the pipe, and then once you are up against the pipe and really starting to get some resistance, what happens is once you get to 90 foot-pounds approximately, plus or minus 5%, but typically about 90 foot-pounds, what happens is this nut will actually break right off. And this is an 1.25 inch nut, same size nut as the T-head bolt, so the operator's using the same wrench, okay? And what happens is when we manufacture these on the collar bolt assembly, part of the casting is this little ductile iron tang here, and this twist-off nut fits right onto the tang. And again, at 90 foot-pounds, turning clockwise, this is expanding. It's setting the wedge into the pipe. It's expanding. This collar bolt is riding into the gland, and it's building force this way because it's spreading apart. This is reverse thread, and it's spreading it apart. And right at about 90 foot-pounds, this will just shear right off. And what it does is it actually takes off that whole little top vertical portion of the tang, and what it leaves behind is a 5/8 nut, okay? And that is for disassembly, for reuse, etc. So even though these have twist-off nuts, and I'd probably venture to say, 98% of the time, once they're broken off, they're installed and nobody ever uses it again. They can be reinstalled, they can be loosened up and reinstalled as long as you use a 5/8 wrench. Go ahead and disassemble the thing. You can, completely disassemble it, put it on another piece of pipe, etc. And you can reuse it. The only added step when you want to reuse it is then you have to use a 5/8 socket on a torque wrench and tighten it up to 90 foot-pounds, because by then we've lost our twist-off nut, our auto torque feature basically. So that's something that is fairly common that, again, some of us in the room that are dealing with shipping and handling the goods and customer service, a lot of times you may get a call from a contractor, hey, you know, my twist-off nut's missing, or hey, these wedges are all busted, what do I do with the thing? Can I use it? The answer is yes. Just tell them, use a 5/8 nut and take it down to 90 foot-pounds. And that applies for all the products. They can be reused, and sometimes the twist-off nut will get broken or dinged in shipping. It happens, so it's something that you need to know. All of the products are made 100% of ductile iron. Okay, so again, corrosion resistant. They're going to be in the ground as long as the pipe, valves, or fittings. That's the way we warranty our product. We'll attest to that if we need to for a certain job or something. Nick, if you're quoting. All of the products are rated to the same working pressure as the pipe that they're going to be installed on. For instance, in ductile iron pipe, small diameter, it's 350 psi. Everything is pressure tested and safety tested, 2-to-1 safety factor. In larger diameter ductile, it's 250 psi, 2-to-1 safety factor, exact same as the pipe and fittings. And the same holds true with the PVC. With the C900, typically it's 150, and it's either a 3-to-1 or 4-to-1 type safety factor, depending upon what DR class of the PVC pipe is and what diameter the PVC pipe is. Here's our demo trailer that is available for shows, open houses, engineering calls, water district calls, training, etc. And basically, it's just kind of it's a live working little water system in terms of mains and restrained fittings. And what we do typically, but we're not going to do today, is we'll pressurize this line, we'll fill it with water, we'll bleed the air out, and then pressurize it up to 200-300 psi to demonstrate to the cities that they can use these restraint products again without using shackle rods or without using thrust blocks. There's no thrust blocks on this trailer. And it's just a good illustrator for how easy the products can be installed and how effective their uses can be. So we recently completely rebuilt this thing with all the new coated product, as you can see. And again, just for identifiers, on the PVC Megalug, the 2000 PV series, it's orange. And that's how you identify it versus the black ductile iron 1100 for ductile iron pipe. And something that Nick pointed out is that our Mega Flange product, we didn't cover this in the class earlier, guys, so our Mega Flange product is a dual use product. This can be used on ductile iron or C900 pipe. It can also be used on iron pipe size PVC through 12-inch. There are a series of spacer washers. You see those little black spacer washers? If those are removed prior to tightening up the wedges, and you use an IPS transition gasket, which are available from Romac and your other type gasket vendors, then this product can be used on iron pipe size PVC. By removing those washers, what it allows to happen is it allows that these wedges to travel down a little bit further to grab onto the iron pipe size OD, which is smaller OD than C900 or ductile. So basically what we have here is, we'll start down from this end, a mechanical joint cap, MJ cap with a PVC Megalug here. And again, we talked about the installation, but make sure the pipe is clean, make sure it's deburred, free of debris, etc. Beveled or non-beveled doesn't particularly matter on the plain end here, but the gland and the gasket are drawn up into the MJ bell by tightening these T-bolts. That's done in an alternating manner, and according to C600, depending upon what diameter, there are specific torque values that these bolts are supposed to be tightened up to. Again, what we recommend is following that torque spec, but if you can't, at least make sure that it's drawn in evenly, and try to gauge the amount of thread showing to make sure that it's drawn in there evenly to get a good seal. The next step is to go ahead and actuate the wedges by hand tightening them all in a cross type manner. And then once they all get fairly tight and start to make contact with the pipe, then what you do is you actually physically start to twist them off. And all these nuts have these twist off nuts, guys. Remember the tang that we had in the classroom that had the twist off nut on top of it? It shears off completely flat. And what's left behind is a 5/8 nut here for disassembly, removal, reinstallation, etc. So this is what you'd use for PVC pipe in an MJ fitting. Let's just say it's an above ground line like this is. This is above ground, which means everything needs to be restrained. Or again, it's sandy soils, poor soils, whatever. We ran our joint calculations, or the engineer did some design, and he determined that 30 feet from the fitting need to be restrained. Well, within that 30-foot length, there happens to be a push-on joint. Okay, this is just a standard C900 push-on joint bell. There is no gasket assembly currently available for PVC pipe within the bell to restrain it. So in this case, you'd use what's called a harness being an external device. There's two split clamps. They clamp above and below, and then they are connected with a series of these rods. Depending upon the size, the diameter of the pipe dictates the amount of rods and the size of the rods. In this case, there's just two, one on each side. And these are available either in a serrated type design. The inside of this casting is machined with serrations, grooves that are grabbing the pipe right now, keeping it from separating. And/or there's also designs that incorporate our wedges also. It just depends upon the diameter. But again, that's just keeping this joint from separating. We move on to our flange fittings. Flange fittings are not super common underground for burial service. However, very common for pump stations, vaults, meter pits, blow-offs, you know, those kind of applications where they're going to be hooking up some type of flange device to a flange fitting, a large meter, etc. And what this is our Series 2100 Mega Flange, and this is a combination product. Even though it's orange in color, it can be used on ductile iron pipe or the C900 or IPS plastic pipe. So it is a combination product. It utilizes a typical standard flange pattern, and what's different about this is there's called a gasket ring between the gland and the flange face. This gasket ring incorporates an O-ring. There's an O-ring surface that seals the face of the flange, and then there's a traditional MJ-like gasket on the gland side that flows into the gasket ring that makes a seal against the pipe. What's real nice about this FCA is because there's two sealing surfaces against the flange, against the pipe, that allows you to actually leave a gap from the end of the pipe to the face of the flange. And that gap's really important, particularly in the type of applications we just talked about, meter pits, etc., where a lot of times a flange device, they are removing, you know, semi-annually, annually, every couple of years for maintenance. Maybe it's a PRV that gets rebuilt. Maybe it's a meter that gets torn down and rebuilt. So a lot of times they're removing these things in and out of these vaults and pits. And some of the traditional methods of, let's just say, a set screw flange adapter, a uniflange is kind of the trade name. Those are very unforgiving and they don't give you much room. And by having that allowable gap, that's a real nice feature to have, because, you know, piping wants to spread and more commonly expand over time when it's in the ground. So so that's the way this works. By the way, this is available through 36-inch. This is available through 60-inch. These are available also, I want to say, at least through 24-inch, and I believe 36 also. Moving past the flange fitting, and this installs the same way, guys, excuse me, but, you know, tighten up the flange bolts, draw everything together, get the seal, and then twist off the nuts, get the restraint. In any restraint system where there's an external type restraint system, everybody's product, the most important thing is first, initiate the seal, second, initiate the restraint. There's a number of products that try to incorporate both into one, and there can be problems trying to get the seal and restraint all in one. It's always, no matter what happens, first get the seal, then the restraint, because without a seal, then we've got problems regardless, okay? So if there's restraint, it may hold it together, but if it's leaking, no one's going to be happy. So moving past the flange, then we transition to this ductile iron pipe. I think this is class 52. All of the Megalug products, by the way, are rated again to the full working pressure of the pipe, regardless of whether it's the class pipe, class 50 through 56, or some of the new pressure class pipe, 350 and down. We've tested on all of it, and everything is fine, and we're fully rated to the working capacities of the pipe. So ductile iron push-on bell, this is just a push-on gasket, no field lock gasket in there. If somebody doesn't want to use a field lock gasket, this is one of our harness products that would go over a push-on ductile iron joint. Notice the gland that goes behind the bell ring, we call it, is split. We also have a split Megalug available on the spigot side, so this can be used for new construction, or it can be used for an existing installation. Let's just say somebody excavated a line and all of a sudden there's an old push-on joint exposed and they don't know if it has a field lock gasket or not. They don't know if it's restrained. You can get a split Megalug and put it on the spigot side. You can get a split backup ring, put it on the bell side, tighten it up with the bolts. It's not going anywhere now, okay? So that's a nice product to be made available for those kind of applications. Those are available through 48-inch diameter. We have the Series 1100 Megalug available through 48-inch, just your standard Megalug on both sides here. And again, twist-off nuts to ensure proper installation, and typical T-bolt installation per WWCL1. Transitioning to the very end here, and some of you guys might want to take a look at what this split Megalug looks like. This is a repair product. It's called a split Megalug. It's actually, the gland is cut in half, and it's split here and it's split here. And then there's a backup washer here that joins the two split halves, and the T-bolts are drawing it into the bell to make the seal. But where this comes in real handy is, again, for existing applications where maybe it's a hydrant shoe or some type of fitting, and the concrete thrust block that was behind this fitting sloughed off, or a guy with a backhoe caught it and tore it out. Now you need to restrain it, but if the contractor or city person doesn't want to totally remove this joint and disassemble it, maybe it's a tight quarter or something, all they can do is the existing follower gland that's on there in those T-head bolts, they can either burn it off or cut it off, clean it up, remove the gasket by burning it out or digging it out of there, you know, because this may be up against a wall or something, you never know. And the split gland will just simply split on. There's an overlapping cut gasket that overlaps, cuts on. You walk in the gasket, join the two halves of the gland, walk the gland in, assemble it, and now you're in business without having to totally remove the fitting, disassemble the joint. And those are also available through 48-inch. Another specialty product that EBA Iron manufactures is a product called a Flex Tend. And what it is it's a series of ball joints, ball joint on each end. And what these are specialty joints that are designed to add flexibility to your pipelines for either above or below ground applications. And the primary application is for things like water tanks, reservoirs, treatment plants, bridge abutments, you know, where there may be a water line on a bridge and then it's transitioning into the soil. Anywhere, or pipelines crossing shear planes or fault zones, or very poor soil conditions. Anywhere in your pipeline that you feel you need to have deflection capabilities as well as expansion capabilities. These units have a series of sleeves that allow expansion and contraction capable, flanged end connection, or a combination of both. And they're available through 60-inch, I believe, as well. So some large diameter stuff get to be very large, but there's a number of these sold for bridge crossings and tank connections, those kind of things, where for seismic concerns or whatever, basically what they want to do is isolate a structure from the soil. You know, if there's going to be any kind of event going on, typically the most amount of movement is going to occur, or the most amount of stress on that pipeline is where there's a rigid structure versus a soil type condition, and that's where you're going to get movement, and that's where these units can allow flexibility and prevent the pipelines from rupturing and pulling apart.